Okay, so let's get started. So with your exponents, right, we have a couple of laws. So the first one, I'm sure you're familiar with it. It says if you have x to the power of n, this will be equals to x times x times x until, right? For example, let's use x to the power of 4. X to the power of 4 is basically x times x times x times x, right? You guys are familiar with this. And the second one is we have x to the power of negative n, which is equals to 1 divided by x to the power of n. Remember, if we have a negative exponent, we can take this whole thing to the denominator, and then the exponent will change to a positive, right? So another example of this would be, let's say x to the power of negative 2, right? So this will be 1 over x to the power of 2, and then basically just 1, this is equals to 1 divided by x times x, right? But you don't need to do that. Okay, so the third law that you have as well is that if you have 1 over x to the power of negative n, right? This is equals to, remember, we can take this, all we need to do, we just need to change the position of this. If we take it to the top, right, the exponent changes to a positive. So we'll now have x to the power of n, right? So your example, we basically have 1 over x to the power of negative, let's say 4, right? This will basically change into x to the power of 4, right? So these basics may seem, not important currently, but trust me, you really do need them. You really do need them to make sure that any other chapter when we head forward does not disturb you, right? So I'm sure the last one that I wrote there, you do know it, and it says x to the power of 0 is equals to 1, all right? So do you guys have any questions? I'm assuming that all of you guys know these laws by now. Okay, so we have another one that says if you have an x to the power of m and you multiply it by x to the power of n, this is equals to x to the power of m plus n, right? So remember, if you have two bases that are multiplying with each other, you add the exponents, right? You add these exponents, as you can see with what we did over there, right? Same thing as we divide two bases. When we divide two bases, we minus the exponents, right? So we would have x to the power of m minus n. I'm sure you guys are very familiar with those, right? And then let's just head forward. This one is a pretty simple one. If you have x to the power of m divided by x to the power of m, these cancel out, you get a positive 1, right? Pretty basic stuff for now, right? Okay. Number 7, we have x to the power of m multiplied by n, right? And also, these may seem like a lot. I'm not going to show every single law to you, right? Because some laws, they're really unnecessary. They're just, straightforward. When you see them, you're like, okay, I need to do this, and then I'll get to the answer, right? So I'm taking the most important ones that you will always have to know and have to use. So we have x to the power of m to the power of n, all right? If you ever have something like this, just take this n and multiply it to the m over there. So you would have x to the power of m times n, all right? So for example, this would be, let's say we have x to the power of 3 to the power of 2, right? This is basically telling us that we can say x to the power of 3 times 2, which is equals to x to the power of 6. You can also use your other law that we learned previously with the exponents, right? You can say x to the power of 3 multiplied by x to the power of 3. And then what happens when we have the same bases multiplying with each other? We add the exponents, right? So this would give us x to the power of 3 plus 3. So, any questions, guys, with what we have done so far? If you understand, just put a thumbs up. I feel like you guys are 100% with this, right? Guys are 100% with this. So, okay. So I'm gonna move on. And then now I have, and before I move on, actually, right, this also applies to when you have a negative exponent, right? Maybe when you have x to the power of m to the power of negative n, right? So remember, anything with the power of a negative, you just take it to the denominator. So you say x to the power of m to the power of n, right? And then you would just simplify it. So it will be 1 divided by x to the power of m times n. Okay, proper. So now let's continue. We are almost done with these laws. So if we have x to the power of 1 over n, all right, do any of you remember what we need to do to change this into a root form? What? Just type it in the chat. What we need to do to change this into a root form, right? This is in exponential form. I want it in root form. Just type in the chat what I need to do in order to take this from exponential form into root form. So basically, this form. Square root n of x proper, right? And then that 1 remains over there, right? So this also works the other way around, right? If you have the n root of x to the power of 1, right? You can just change it back into the exponential form, and you would have the n go into the denominator, right? That's always the case. The denominator, the root always goes into the denominator, all right? And then likewise, when you have a negative exponent, right? When you have a negative exponent, you always first get rid of that negative exponent, right? And that you do it by changing its position. So you change its position from the numerator to the denominator, or vice versa. And then you can do such laws, right? So you first start off, let's say we have an example like x to the power of negative 1 over n, right? You need to first get rid of this negative exponent. And how do you do that? You just change this to 1 over x to the power of 1 over n. And then now you can change it into a root form or surd or whatever you may want to call it. So we now have 1 over nth root of x, right? And that's it. And then now I'm only going to do 2 more and then we can move on, right? I feel like you guys are 100% with all of these. And then we will head on to rationalizing the denominator. So, number 9, we have that if you say the nth root of x multiplied by the nth root of y, what happens over here is we have something in common. We have the nth roots, right, in common. So since we have the nth root in common, we can place it under one thing and then the bases, so the x and the y will multiply with each other. All right. So for example, if you have 3 to the power, sorry, it's 3 cube root of x multiplied by the square root, or the cube root of y. You just say the cube root of x multiplied by y. As simple as that. Yes, the lesson has been recorded. I will upload it on YouTube as well, right? I'll upload it on YouTube. I'll just send you guys the link, and I think I'll upload it on WhatsApp as well, so that people can access it. Okay, so I think this would be the last one. And remember, if this works for multiplication, right? If this works for multiplication, and then for division, it's just it's just the same thing, but you probably have a, okay, so for example, let me show you this one for the for division. We'll have the nth root of x divided by the nth root of y. We do the exact same thing we did over here, and then we'll just divide the two bases. So we will basically have the nth root of x divided by y, right? Pretty straightforward. And then now I am almost done. This is the last law. I think this is the 11th law or 10th law. So the 10th law tells us that if we have the mth root of the nth root of x, right? What do we do to this? All we need to do basically is we just need to multiply these roots. So we'll basically have m times n square root of x. And that's it. Because I want to see if you guys understand it, right? Okay, did someone raise up their hand? Okay, perfect. Everyone is understanding. Okay, Renelwe, please, what do you call it? Ask your question. Just please raise up. Okay, the last law, you don't understand it. Okay, maybe let me show it in another way, right? Okay, so maybe let me show you how I got to how we get to that part, right? So remember, right? Remember, let's leave the mth roots alone over there, right? Let's leave the mth roots alone over there, and let's first change this part. How do we change that part? We can always change it into your, what do you call it? You can always change it into your exponential form, right? So I'm just freestyling it now. Let's see if we can get to the same conclusion that we did over there. So this will change to this, all right? And the next one, what will it change to? It will change to x to the power of 1 over n. And this whole thing, it will be in the numerator, and it's divided by m, right? Are you guys still with me there? So I'm just showing you how we got to that. So if you ever maybe don't remember it, then you see that how I actually got to that law, right? Or you can just cram it and say, if you have a square root on the outside and you have another square root on the inside of it, you just multiply the two roots, right? So over here, let's continue over here. What do we do when we get to that point? We will basically have x to the power of 1 over n, and this is divided by m, right? And then what happens when we change it into a multiplication? The position swap, right? And this is now what we have. Do you guys see where this is headed? You guys do see where this is now headed? So now we have x to the power of 1 over n times 1 over m, right? And one thing I want you guys to know, when we multiply fractions with each other, we multiply the numerator with the numerator, and we also multiply the denominator with the denominator. So what do we now have? We now have 1 times 1 in the numerator is 1 divided by n times m, which is n, m. And then now let's change it back into a root form. So we now have n, m root of x. Do you guys see how we got to that? Just put a thumbs up if you guys are okay with this. Okay, perfect, 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 perfect. So you need to actually be able to derive such laws, right? Sometimes it happens, you don't know all the laws, right? Even I do forget laws sometimes. and then I just have to derive them, right, by using other laws. As you can see, we use the multiple laws here. This law already, we know it. We use multiple laws to get to another law, right? So you need to be able to do that. You need to be able to manipulate the equation, right? Or manipulate the thing that you need to simplify, right? The expression, right? So I'm going to teach you guys how to, manipulate equations, and also how to think in that way, right? How to think in the way of manipulating and deriving equations, right? Now I would like us to go to rationalizing the denominator, right? So this one is pretty simple, but I think there's just one more thing that's added from last year, right? From last year, you only did the conjugate one and the normal one, right? Right now, there's a new one that's been added. There's a new part that's added, right? It's very short though. So let's rationalize the denominator. Okay. So I'm gonna start off with the easy one, right? So with rationalizing the denominator, let's say we have 9 divided by the square root of 7, right? So I would like to hear from you guys. What is the point of rationalizing the denominator? You can just type it in the chat if you know the answer, right? What is the point of rationalizing the denominator? Let's go, guys. Let's go, let's go, let's go. I want to see, I want to see, I want to see. At least 10 people must answer. I'm assuming you guys are still typing. Okay. Agnes, you may answer. I see you raised up your hand. Just please unmute yourself and answer what I just asked. If anyone else also thinks they know the answer, then you can just also ask, right? Or answer, sorry. To simplify the calculations. Okay, we are simplifying something, right? But what's the point? What are we doing? What are we doing? What's the main goal of rationalizing the denominator? To get rid of the square root in the denominator. Perfect, 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 guys. Yes, yes, that is 100% correct. We do not ever, we don't want to deal with roots in the denominator, right? So two things that I'm gonna tell you guys, right? We don't want to deal with square roots in the denominator, and we also don't want to deal with negative exponents, right? Those things, those two things, we do not want to deal with them. We always try to change them into their positive versions, or likewise over here, we always try to get the surds or the roots into the numerator, right? So always keep that in mind, please, guys, please, guys. It's much easier to, write down your answer in positive exponents, and also your answer rationalized, right? But you don't always have to rationalize, unless they ask you to rationalize. So what can we do to rationalize this? We are trying to get rid of just the square root in the denominator, right? Remember, if we multiply a square root and we multiply it with another square root with the same base, what happens to the square root? Remember, square root is basically x to the power of 1 over 2, right? There's a 2 over here, and there's also a 2 over here. And when they multiply with each other, basically what happens is we add the exponents, and the bases, we keep one base. And then we add the exponents. So we basically have 1 over 2 plus 1 over 2, right? And as you can see, it will be x to the power of 1. And as you can see now, we have actually gotten rid of the root in the denominator, right? So how do we do that to this portion, and we do not so that we do not also change the expression, right? So we will say 9 over square root of 7, and we'll multiply this with the square root of 7 as well in the denominator, right? So that we can cancel out the roots. But now this whole expression right now, right, is different. This expression is different to what we have originally, right? So how do we make that the same expression? We will just have to multiply by a 1, right? And multiplying by a 1 means that in the numerator, I have to say the square root of 7 as well. So that this whole thing is just the 1. And then this expression, as you can see, is still the same as the top part, right? Are you guys okay with this? Pretty straightforward. So that's basically, how you do it every single time. Perfect, 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 perfect. Now, let's simplify everything, and then we are done, right, with this part of rationalizing the denominator. And also, guys, if you have any questions, don't be afraid to ask, right? I am here to help you. So we have 9 times square root of 7. Remember the numerators, we multiply each other, and the denominators will also multiply with each other. So we have square root of 7 multiplied by square root of 7. This will just give us a 7, and we are done. All right. Okay, so now let's do the conjugate one. Let's refresh your memory, right? Let's say we have, let me make a quick example. Let's say we have 9 divided by the square root of x plus, sorry. Okay, the square root of x plus 5. All right, let's say we have something like this. So how do we do these types, right? And how do you know that it's a what do you call it? It's a conjugate type of rationalizing the denominator. You will see that in the denominator you will have 2 terms. The moment you have 2 terms in the denominator, right? This is not 1 term. If it was 1 term, it would be like this. This whole square root will cover the plus 5 as well, right? So if you see that there are 2 terms in the denominator, then it needs to click to you that, no, I need to do the conjugate part of rationalizing the denominator, right? And the conjugate of this would basically be the square root of x minus 5, right? And remember, what we do in the denominator, we also do to the numerator. Right? And the reason why we do the conjugate is because eventually we allow square roots to cancel out. If you keep it a positive, there is definitely always going to be a square root that remains in the denominator, right? So if you do not change the opposite to the opposite side, even if this was a negative, right, you would have to change it to a positive. Sorry, if this was a negative, let me just do this. If this was a negative, you would have to change this conjugate to a positive, right? So that you are able to cancel out the square roots at a later stage, right? Okay, so let me show you what I mean by that. So now the numerators will multiply with each other. We'll have 9 multiplied by the square root of x minus 5. And the denominator will also multiply with each other, right? So I remember back in high school, I learned a little thing called FOIL or foiling, right? Or you may call it factorizing. The exact same thing, right? It means the exact same thing, right? So remember, let me just write it down. FOIL. FOIL basically means this is the first one, and this is the outers, the inners, and the last 2, right? So we're gonna start off with the first 2. So let me just do this real quick. Let me just go down. We will start with the first 2, right? So we'll have 9, and then I'm just gonna multiply this 9 inside, right? So square root of x minus 9 times 5 is 45. And I see Bunolo, you raised up your hand. I'll be with you in a second, right? So this is what we have when we just multiply this 9 inside, right? So in the denominator, we'll start with the first 2. So let's start off with the first 2. We will have the square root of x multiplied by the square root of x, which gives us just the x. Perfect. Now we'll start, and then we go over to the outer 2. So this square root of x multiplied by negative 5. That will give us a negative 5 root x. All right. Then we'll go to the inner 2 as well. The inner 2 will be a positive 5 multiplied by the square root of x, which will be 5 square root of x, right? And this is why you need to use the conjugate. You need to change the sign. If you did not change the sign and you kept it a positive, this would have probably been a positive over here and also another positive. And as you can see, you would have the 10 roots of x and you still would be back to square one. You still wouldn't have changed anything, right? You would have a square root in the denominator as well. So that's why it's very important to change to the conjugate so that you can have two middle terms that cancel out. Okay, so now the last two will be 5 multiplied by negative 5, which is negative 25. And also, I would like to urge you guys to, practice maths without using a calculator. You need to be quick, right? You need to be quick with these things. You need to be quick with these things because the tests, there's a lot of things you need to write, right? But there's such small time to finish. And a lot of people probably do not finish because maybe they're not prepared enough or maybe they don't really understand the content like that. But please do not waste time, in your tests and your exams and so forth. Okay, I see Winnie has raised a hand. Please ask your question and I will answer it.
Hi, I wanted to ask, I thought doing BCom accounting would help me avoid math. So, will this help my future accounting career? Will I be doing exponents and radical laws, and will I need to apply this?
Okay, so this part, right? I don't think you won't really you won't necessarily apply it, maybe they will test you on this specifically, but there are chapters like calculus, right? If you're doing economics, you need to know calculus, right? And of course, these are the foundation. This is the foundation. You need to know this in order for you to do what do you call it? In order for you to do calculus. And then in order for you to know to do topics in economics, you also need to know calculus. So there are topics like your marginal propensity to save. So all these topics, you see the maths at a later stage incorporates economics and all those other concepts. So yeah.
Thank you.
Let me hit forward, right? Okay, so now we just need to cancel these two. And when we cancel them, we now have 9 root x minus 45 divided by x minus 25, right? Okay, proper. And then you're basically done. And one thing that I also forgot to touch on, right, at the beginning of the lesson is you have some online, let me call it online tests, right? And these are called web works. And they count 20% of your mark, your FPM, right? Which is your semester mark, right? They count 20% of your semester mark. Guys, please, webworks, make sure you get 100%. I'll definitely assist you with the webworks as well, but make sure you get 100% because I've seen people struggle with the tests. These tests are very, very tough, guys. I won't even lie to you. These tests are tough. They are trying to, basically at UJ or any varsity, they are trying to weed out people, right? They're trying to weed out the best people. So meaning they'll put the hardest stuff in the test or in the exam and so forth. And they're basically they basically want you to fail, right? They want the best of the best. So if you're able to get through such stuff, right, you'll be 100%. Tati, I see you raised up your hand. Then we'll go to Aseko.
Hi.
Hello.
May I please ask, am I supposed to be in this class because I'm doing the Common Finance, the extended program? So is it okay for me to be in here now?
So the BCom Finance Extended, don't you guys have MAEB as a module? Basic mathematics And
So I'm not
basically,
supposed to be here.
no, I'm just asking, do you have a basic mathematics module?
Yeah.
Okay, so yes, this is what you will be learning as well. Then I'll just make a separate group for you to join as well, for the MAEB as well. And yeah, so I think that's fine. And then yeah, Aseko.
Hello, I wanted to ask if will you also continue assisting with business mathematics?
Yes, yes. So I tutor business mathematics, I tutor introductory mathematical analysis, and I also tutor MAEB, right? So all the maths that they offer, I tutor them. So I'll definitely be continuing with it.
Okay, thank you.
Pleasure. And then who's next? Let me just check. Radilwe. I see you raised up your hand. Okay, perhaps it was a mistake. So let's continue. And then the last type of what do you call it? The last type of rationalizing the denominator, right? Maybe for some of you, it might not be new, but for most people, it most definitely would be new, right? So let's say you have 2 over, let's say the 6th root of x, right? How would you rationalize such a equation? Do you guys have any idea? Just type it in the chat how we would rationalize such a question. So you have 2 6th roots of x. And be careful with this one, guys. Please be very careful with these types. So I'm going to check in the chat, or someone can just raise up their hand and tell me, how do you rationalize these types? So someone said, do I need to attend if I don't have business mathematics is my module doing BCom accounting? So BCom accounting people do introductory mathematical analysis, right? So all the chapters that you guys do are the same. The ones from business mathematics, they just do it at a faster rate. And then what do you call it? Introductory mathematical analysis, right? They stop at a certain chapter as well. It's very fast paced as well, but they stop at a certain chapter. And then the MAEB, they do it like at a slower pace, the extent that they do it at a slower pace because they're trying to introduce it to you, right? Okay, so yeah, definitely you are in the correct class. So I would like someone to tell me, how do you rationalize this? So does anyone have an answer to my question over here? It's 2 over x. Okay, so is it 2 over x powered by I over 6, 1 over 6? Okay, remember, yes, okay, that's basically it. Yes, it's basically this. So remember, we are trying to get rid of the roots in the denominator. So what will we do? And then I saw someone just raise up their hand. Didn't quite catch the name. Okay, let me just quickly check. I go. Come on, guys, come on. Let's hear it. Okay. So basically what we would need to do in this one, right? We would first have to, change it to, your exponential form. So I'll write it as 2 divided by x to the power of 1 over 6, right? And remember, I'm trying to get rid of the root form, right? So this fraction in the exponent, I do not want it. I don't want anything like that, because this is still exactly the same as this. I have not done anything, right? So now, how do I get rid of that root or exponential fraction in the denominator? I have to multiply this by x to the power of 5 over 6. And the reason I'm doing that is because when we add these two together, they need to add to a positive 1. Are you guys with me on that? So the reason why it's 5/6 instead of 1/6 over here is because I need to add the exponents and make it a 1 in order for me to get rid of this root, 6 root over there. So just put a thumbs up if you guys understand this. So please be very careful of these types, right? And then Sandila, I see you also raised up your hand. Okay, maybe resolution. Okay, Slungile, you may ask a question.
Sorry, I just wanted to ask for the x 5/6. Do you take the denominator and minus 1 and get the 5 above?
Okay, you mean for this 5, how do we get to the 5?
Yes.
Okay, so basically the way we got to the 5, right? Remember these two things, if you have a 1/6 over here, right? I need to get to a positive 1. And the only way I can get to a positive 1 is if my exponent that I'm multiplying with, right, is 5/6. Because now I can add these two, and then I just basically 6/6,
Yeah.
you check.
Thank you, I get it.
Okay, pleasure. So whatever you get over here on that 5 position is dependent on what you have initially, right? Then do not forget to do the exact same thing in the numerator. That is very important, right? So now we have 2 multiplied by x to the power of 5/6. And this is divided by x, right? Okay, so someone else has raised up their hand in the chat. Let me just check.
Oh, I just saw it, Mr. Saying you need.
Okay, not a problem. So let's simplify it further, right? So we see that this became x to the power of 1, so that's fine. And then yeah, what I would like you to do in the numerator, you can leave it as a root form, right? So you basically have 2/6 roots of x to the power of 5 divided by x. So I think everyone is okay with that, right? So I've covered all the different types of rationalizing the denominator, right? If you can just remember these 3, I assure you, you're always going to get full marks with rationalizing the denominator, right? And then I see Slungile. Did you also raise up your hand again? Okay, perhaps there was a mistake. So if you know these 3, right, in whatever form they can give it to you, as long as you know that format that I just show you, then you will be 100%. Slungile, I see you raised up your hand.
Sorry, I just wanted to ask, is there any problem where you have square roots on 2 square roots on the denominator?
Yes, if you have 2 square roots in the denominator, so I think you mean it like this, right? So let's say we have 5, right, divided by maybe a square root of 5. Oh, no, sorry, not a square root of 5. Okay, yeah, let's keep it a square root as 5 plus the square root of y. Do you mean something like this?
Yes.
Okay, so yes, you definitely do get such type of questions, but remember, just stick to what I told you. Don't get confused by what they're trying to do over here, right? They're just trying to confuse you, but do not get confused. What happens here is you have 2 terms, and when you have 2 terms, remember, just multiply it by its conjugate. And then eventually, somehow, someway, they will cancel out. So you will basically have square root of 5 minus the square root of y divided by the square root of 5 minus the square root of y. And then you see that they will cancel out. Are you okay with this?
Yes, thank you, I get it.
Okay, perfect. So please, guys, don't think too much about it. If you just stick to what I just taught you guys, I'm telling you, you're definitely going to get full marks for this. All right? Okay. So we are done with rationalizing the denominator. I would now like to go to the next chapter, right? And then every week I would like to give you guys homework. Are you guys fine with homework? I think it'll make sure that you guys, stay ahead with your work or stay up to date with your work, right? Because I understand, hey, varsity sometimes, guys, it's nice here, but sometimes you may even forget that you're here for course, right? You just wake up one day and then you like, no man, actually I came here for school. You check. So please make sure that you stay up to date with all your schoolwork. Is this going to be revision of grade 12 work? Do you mean the whole course? The whole course won't be revision of grade 12 work. There are new topics that will be added, right? So they just, they start off with these topics to make sure that, just to make sure that you understand the basics. And then we move on to the more difficult stuff, especially the financial maths and the probability. That one is now difficult. Okay. Even that thing of substitution, right? It's more difficult now. So you will do it with 3 variables instead of 2, right? Initially, you had maybe something like this: x plus y is equals to 6. And then you have another thing like, 2x plus y is equals to 7. Now it changes, right? You will have an additional variable like x plus y plus z is equals to 7. And then maybe let's say x minus 2y plus 3z is equals to 4. Then maybe we have another line as well that says x plus 2y minus 4z, right? So there's a couple of topics. There's a lot of new topics. Even chapter 7, which is linear programming, they are very, very new topics, right? That's why people struggle with it, because initially they underestimate it, right? They underestimate this course because they like, I've done this in high school, I've done these chapters in high school, and then they stop attending classes, right? Now the simultaneous equations will be there, right? But you are more likely to get asked these types, right? So as I was saying, people underestimate this, right? So in the first week or first 2 weeks, you'll be doing something that you're familiar, you'll be doing stuff that you're familiar with, right? And then a lot of people stop attending. I'm just being honest. A lot of people stop attending, and then they get to the test, and then they said that they send you the scope, right? They tell you that everything that you have done so far is what you're writing on, and then they see new chapters, and that's where the problem comes, right? Because those new chapters are actually difficult. Okay. So someone asked, what about the B? Okay, I'm not too sure on what that was referring to, right? But I'm just going to continue now. I'll just like to do a couple of simplifications. Okay, but no, those simplifications, we have done them before. I would now like to do some simplifications of... So simplifying radicals is pretty simple. You just need to break it down into a smaller form, right? So for example, let's say we have 4 root of 48. And they want you to simplify this without a calculator, right? I'm sure you guys remember those type of questions. So all you had to do over here is you would, what do you call it? You would keep the roots there, then you just break down the inner parts, right? So what can we break this down into? 16 times 3, you can definitely do that. You can do 2 times 24, right? There's multiple things we can do. You can do 2 times 24, or we can do 16 times 3, right? But I feel like 16 times 3 will be easier to work with because it is smaller, right? We have smaller numbers, basically. That big 25, sorry, that big, what do you call it, 24 doesn't really take us anywhere, right? So if we say 16 times 3, what will we now have? We can now separate these two inner parts, right? You can separate these two inner parts. We'll now have the 4th root of 16 multiplied by the 4th root of 3. The problem with using 24 and 2, right? 24 and 2 will just get you stuck to this point. right? Whereas this part lets you simplify it further, right? So what would be the fourth root of 14? So the fourth root of 14, I think it is 2, right? So 2 multiplied by 4, root 3. And that is the final answer. Is everyone okay with this? Just put a thumbs up. Okay, perfect, perfect. Slungile, I see you raised up your hand. Or was it a mistake? I think you quickly put it down as well. Okay. So, I am now done with this chapter as well. We are now done with 0,3. We'll be heading to 0,4. And Slungile, I think you have a question again. So, okay, please just ask a question.
Sorry, if I leave the final answer to be 2 times 3 to the power 1/4.
Okay,
Will that be
that's 100% fine. That's 100% fine. It's just that it's just good maths manners to leave it, you know, in this format.
okay?
All right, but they will definitely give you your marks. Okay, so let's go over to, you know, your algebraic expressions, right? So operations with algebraic expressions, right? So maybe you guys also want to know the layout, maybe of your first test. Your first test will definitely, I think it will end at chapter 5, which is finance, right? So you will do chapter 5 up until 5,4, which is annuities, right? So everything from chapter 0, chapter 5,4, right? And this will be done in the space of, I think, a month or so. So yeah, that's why we say it's very fast paced. So even worse for the business mathematics, you guys do it way faster as well, right? So that's why we'll be splitting the classes when we open, right? Okay, so let's head forward. So we have operations with algebraic expressions. So sir, how are we gonna communicate? Do you have a group chat? Okay, so as we progress forward, right, and we finish our free lessons, right, we will make a group chat, a paid group chat, and then every student that paid will be, you know, placed into that group chat where I can communicate with you guys, and you can also personally text me, right? You can personally text me or my other number, which I will show to you guys in the, what do you call it, in the group chat as well, right? If this one I'm not answering it. And we also have a website. It's just that now it's under maintenance, right? So our website, you can also access the videos, you can access, you know, you can also communicate with us there. You can also communicate amongst each other on the site and everything. But it's under maintenance right now. And before we open, it will be ready, right? So the 10th, it will definitely be ready by then. Okay, so if there's no other further questions, let's continue. So we now have operations with algebraic expressions. Okay, so operations with algebraic expressions, it's your basic multiplication, addition, subtraction of, you know, your x and your y's. So basically, let's say you have 3x squared y minus 2x plus 1, right? Plus 4x squared y plus 6x minus 3, right? If you have such an expression, right, it's basically just simplifying this expression, right? And I won't really take much time on this because I think you guys will also be okay with this, right? So let's just quickly do it. And this lesson will stop by 20:15, right? So 20 quarter past. So with such expressions, right, we need to look for common factors. So here's a common factor. And how do we find the common factor? We have an x squared over here multiplied by y and another x squared multiplied by y. So that's a common factor. This one, or yeah, we just call it's the same thing, right? And then we have the x, and we also have an x over there. Then we have this constant and another constant over there, right? So those are the only ones that can add to each other in this case. So this is addition. So we have 3x squared multiplied by y plus 4x squared multiplied by y. That gives us 7x squared y. And then we have negative 2x plus 6x. That leaves us with a positive 4x, right? Positive 1 minus 3, which leaves us with a negative 2. And that will be the final answer. And then Penina, I see you raised up your hand. Okay, perhaps it is a mistake. And that's basically it for addition, right? That's nothing complicated. So you just look for, the same thing. You just look for terms that look the same, right? So if the terms don't look the same, don't ever add them or don't ever subtract them, right? Because, addition and the subtraction part, it's quite very, very similar. Please don't complicate it. It's just that straightforward. So let's do the subtraction, the exact same one, but for subtraction, then you'll see how it differs. So for subtraction, one thing I don't want you guys to do is to forget to multiply that negative inside, right? So if you multiply that negative inside, you need to multiply it into each term. So this is now what we have, 3x squared y minus 2x plus 1 minus 4x squared y minus 6x plus 3, right? And then now you can add the common terms to each other, right? So sorry, I was saying common factor, it's the common terms basically, sorry. So 3x squared y minus 4x squared y is negative x squared y. And then negative 2x minus 6x leaves us with negative 8x. Then 1 plus 3 is a positive 4. All right. Then let's move on further to the multiplication one, right? And the division, multiplication and division. But before we move on, I would also like to show you this one, right? Where we have 3, that's called removing grouping symbols. So please, guys, I'm just begging you, please do not underestimate this chapter nor this module, right? You heard your, what do you call them? The lecturers, they were saying that this module, a lot of people fail it, right? So, class 5, my bad. 4x squared minus 3 minus 4x, and then we have this, right? So how do we simplify such equation, right? So they just want us to simplify over here, and simplifying it. Hey man, what's going on now? Okay, just wait, sorry. Okay, my bad. So how do we simplify this, right? In order for us to simplify this, we just need to start by the innermost brackets, right? Starting by the innermost brackets, I believe, is the best way to simplify these type of expressions, right? Because I feel like, multiplying this 3 inside over here, and so forth, you could make a mistake somewhere, somehow, right? So personally, I like to start with the inner brackets and then expand to the outside, move on to the outer brackets and simplify it that way, right? So let's start off. We have 3, let's leave it on the outside. Multiplied by this 2x, I'm going to multiply it inside that bracket. And we have to multiply it in those both terms. So we have 4x squared. And the 2x multiplied by the 3 will give us a positive 6x, right? Plus the 5 multiplied by 4x squared, right? So 5 multiplied by 4x squared. And before I do that, let me actually first multiply the negative inside. So I will leave the 5 on the outside. And then I will say 4x squared minus 3 plus 4x, right? So that it looks more comfortable to the eye. So 3 multiplied by 4x squared plus 6x. Then now I can multiply the 5 inside. So this will leave us with 20x squared minus 15 plus 20x. And then once you reach this point, you can see it's very easy. You can either add these two and add these ones, and then you multiply your 3 inside, or you can first multiply your 3 inside. So whichever way is fine. You can do whichever way, right? So I'm going to first multiply, or actually, let me first add the numbers first, right? So 3 multiplied by 4x squared plus 20x squared will leave us with 24x squared, right? Then 6x plus 20x leaves us with 26x. And then negative 15 remains as well. And then let's head forward. This 3 multiplied by 24 should give us 24, 48, and the next one is 62, right? X squared, if I'm not mistaken. Or 72, sorry. And the next one is 3 multiplied by 26. So that's 26, 52, and then 70, 76, 74, 78. Okay, perfect. And then negative 15 times 3 is negative 45. And that's your final answer, right? And then I think it's 2015 now, right? It's _8. So we will continue with this. Just check the schedule. I'm gonna place another class on the 7th, right? I'll place a class on the 7th for us to attend so that we can just finish this chapter real quick in this week before you attend. And so basically we had a class today on the 7th and also on the 10th, right? And we'll be dealing with chapter 0. And after that, we'll go over to chapter 1. We'll go over to chapter 2 as well, and so forth, right? The new chapters. When will we be having business mathematics 100th session? So for now, the business mathematics, we are all attending together because this chapter we all do it, right? Everyone does it. So from the 10th of February, when we open, right? When UJ opens, classes commence and everything, right? That's when we will separate everyone. Right, so we'll separate everyone to their respective classes. So for now, any class after this one, we will have a class on the 7th, and we'll also have a class on the 10th as well. And that is the last class. Everyone will be together, and then we will have a separate class for Introductory Mathematical Analysis. We'll have a separate class for Business Mathematics 100. We'll also have a different class for MAEB as well, right? Do we need a financial calculator? Yes. So at a later stage in finance, right, you will be required to calculate your annuities, and your amortizations with the use of a calculator, a financial calculator, right? If you have any questions, just ask on the group chat and we will respond to you. So thanks for attending, guys, and have a great night.